Okay, so on this video, we're going to review how to solve what we call 2x2 systems of equations. Just means that there's two equations and two variables. We're going to review how to do that algebraically on this video. The other video, we reviewed how to do that by graphing. So there are two types of algebraic solutions for these systems, both of which you learned in Algebra 1. The first is solving by substitution. So we are going to write substitution up here, and we're going to write the steps out over in this column, leaving enough room for us to solve over here. So you'll want to write kind of small, but I write kind of big. So if I can fit it, I would think you should be able to fit it. When we are solving by substitution, our first step is to get one of the variables alone. Isolate, in other words. Now, what do you want to look for? Because I am a huge fan of trying to make things as easy as possible on yourself. And there are four choices here for what variable to get alone. The x in the top equation, the x in the bottom equation, the y in the top, the y in the bottom. But there's definitely a choice that is better than the others. Doesn't mean that it won't work if you choose a different one, but it just means it's not going to come out as nicely. So what you should be looking for if you're going to use substitution is you're looking for coefficients, meaning the numbers in front of the variable, of 1 or -1. If it has a coefficient of 1 or -1, substitution is going to be an easy choice. So in this particular example, our step 1, and by the way, you do not have to label your steps when you solve. I am just going to do it in the notes so that you can look at the steps and match up what we did here. We're going to choose that bottom equation, and we're going to choose the x because it is the only one of the four that has a coefficient of -1. So if I want to get that x alone, the first thing I'm going to do is subtract the 2y. So opposite operations. Remember that when we do this, these are not like terms. You can't take 5 minus 2y. Don't tell me that's -3y or something crazy like that. They're not like terms, so leave them separate. -2y plus 5 is fine. X is still not alone there because it has the negative in front, so we're going to divide everything by -1, which simply just changes all the signs. So we are finished with step 1 because we have isolated or gotten one of our variables alone. X is now alone in that second equation. So once I have done that, step 2 is to remove the variable you isolated from the other equation. And put the equivalent expression from step 1, so the expression we just got in step 1, in its place. So here's what that means. Now notice this is key, the other equation. The equation I just used was the bottom one. So when I go to step 2, I should be using the top equation. And I'm going to take the variable I isolated out of that equation. So I'm going to take the x out. I'm going to leave a blank parenthesis. Everything else about the equation should stay the same. So everything about this is the same except I removed the x. In its place, I'm going to put the expression from step 1, which would be this guy right here, 2y minus 5. Now what we've done is we have created a one variable equation that we should be able to solve. So step 3 is to solve the equation. So from step 2. So in this case, that means for step 3, first I'm going to need to distribute. So 4 times 2y is 8y. 4 times negative 5 is negative 20. Plus 6y equals 15. These are like terms over here, so I need to combine those first. That gives me 14y minus 20 equals 15. Add 20 to both sides. So that gives me 14y equals 35. And then divide by 14. Now, that doesn't come out evenly. That's okay. Not all things are going to come out evenly in life. It does reduce, though. 35 and 14 are both divisible by 7. So that gives me 5 over 2. So y equals 5 over 2. Step 4 is plug the answer into your expression from step 1. And solve. Okay, so step 4, we go to our expression from step 1, which was this x equals 2y minus 5, and I'm going to plug in 5 halves in place of my y. So x equals 2 times 5 halves minus 5. 2 times 5 halves is 5. 5 minus 5 is 0. Now, that means x equals 0, y equals 5 halves. I am not done. Last step here is to list the answer as an ordered pair. X, comma, y. Do not forget this. You'll lose half a point every time you do it. You don't want that to be you. So x equals 0, y equals 5 halves. This is our answer. Now remember, you should always be able to check it. If you have done this correctly, when you plug in 0 for x and 5 halves for y, it should work in both equations, not just one. So always take the time to check your work there, just to make sure. I know that it's correct because I've done this more than once. Okay, the other algebraic method that you learned in Algebra 1 is what we call the elimination method. So, totally separate set of steps. That's my work from the other station up there. Sorry, it's running in there. First step in elimination is to get opposite coefficients on one set of variables, so either the x's or the y's, by multiplying one or both equations by a constant. So just by a number. Now, sometimes you might already have opposite coefficients. If you do, that's great. That means you get to skip to step 2. But I, of course, picked ones where we had to do this to illustrate the most work that we could possibly have to do. So it does not matter which ones you pick. You could choose to eliminate the x's. You could choose to eliminate the y's. I personally am going to choose the y's because the signs are already opposite, which means I can multiply by positive numbers. Just multiplying by negatives, people make more mistakes. So again, it's not wrong, it's just a different choice. So I could multiply this top equation by a 5, and that's going to give me negative 20y. I want this to then be the opposite, which is positive 20y, which I could get if I multiplied this bottom equation by 4. So I am multiplying both equations this time. Sometimes you only have to multiply one. Like if your bottom was, 6y and the top was 2y, you would just multiply the 2y by negative 3. But here, the most complicated situation we could have is multiplying both. Remember, you have to multiply the entire equation. So 5 times 7x is 35x. 5 times negative 4y is negative 20y. 5 times negative 3 is negative 15. Sorry, my equal signs didn't come out very good there. Bottom equation, 2x times 4 is 8x. 5y times 4 is positive 20y. Negative 7 times 4 is negative 28. So step 1 is done. I have opposite coefficients on my y's there. Step 2 is to add the equations together in columns. Now, this brings up another point. Usually if we're going to use elimination, it's already lined up in columns, but if they weren't lined up at the beginning, you would have to do that first. So I'm going to add the equations now in columns. I'm going to use a different color here. So this is step 2, add them together. 35 plus 8 gives me 43x. Negative 20y plus 20y is 0. Those are canceled. And then I have negative 28 plus negative 15, which is negative 43. The reason why this is called elimination is because we eliminated the y's. So we did that. Step 3, as you might imagine, is to solve the equation that remains. So in this case, it's a pretty easy equation to solve. All I need to do here for step 3 is to divide by 43 on both sides. So I get x equals negative 1. Okay, so once I have done that, then step 4 is to plug the answer into an original equation. And solve. So, step 4, I'm going to plug negative 1 into one of the originals for x. Doesn't matter which one you use. I'm just going to use this one because 2 is smaller than 7, but it doesn't really matter. So 2 times negative 1 plus 5y equals negative 7. So that gives me negative 2 plus 5y equals negative 7. Add 2, so I get 5y equals negative 5. And then I'm going to divide by 5, and I get y equals negative 1. As you might guess, hopefully, step 5 is to list our answer as an ordered pair, x comma y. So our final step here would be to list our answer as negative 1, negative 1. And again, you can check it. All right, now, one thing that I kind of ran out of room for, so maybe if you want to write it like at the very, very top of your paper, which ignore all this, you'll get that in the other video. Algebraically, if the variables drop out, meaning you're going through the steps and both your x's and your y's go away, and the numbers left give you a true statement, then that means that the answer, instead of an ordered pair, is going to be infinitely many solutions. If they give you a false statement, then that means that there is actually no real solution. So an example of this would be if your variables drop out and you get, 5 equals 5 or 0 equals 0. That would be infinitely many solutions. If they drop out and you get like 0 equals 7, that's a false statement that would be when we have no solution. So make sure you write that down. Otherwise, you'll forget, and then you'll be sad when that comes up. All right, hopefully this kind of jogs your memory and it seems kind of familiar. You'll have some practice in your homework.